Today I'm going to show you how to prepare a beta-lactam antibiotic sample for analysis using a test card technique that we have developed. The first thing that we need to do is to prepare the sample for analysis. Here I have a sample of amoxicillin that we collected in the marketplace of Kenya. And we need to create a nominal 1 mg per mil solution of this. This product is labeled as a 500 milligram pill. So I'm going to empty the contents of this pill into this plastic bottle and then add 500 milliliters of water. It is better to get all of the powder out of the pill capsule and into the plastic bottle. You can also just dump the capsule right into the plastic bottle. Now we have to add 500 mils of water. There are a few different ways that you could do this. You could use a graduated cylinder to measure 500 mils of water. You could use a balance and mass 500 grams of water. But what I've done here is I've marked the bottle for the level of where 500 mils should be. So I'm going to dilute this to volume. Now we have to shake this for about 1 minute to dissolve all of the amoxicillin. This is a real pill sample, so all of the contents of the pill may not dissolve. It's been about 1 minute, and you can see that the solution is still cloudy. This is okay because there may be a filler in this pill that is not water soluble. The next step is to pipette 4 mils of the antibiotic solution into a new container. If you don't have a pipette to do this, you can use a balance and mass 4 grams of the solution instead. Two mils of 1 molar sodium hydroxide also have to be added. Again, if you do not have a pipette, you can mass 2 grams of the solution. Mix the vial a little bit, and then start a timer for 15 minutes. Alright, the 15 minutes is complete, so the next step is to add acid to our reaction vial. This can be done in a number of ways. We can pipette 2 mils of the 1.2 molar hydrochloric acid, or we can do it by mass. Here I have a portable scale that's operated by batteries. It's a centigram scale from AWS. If you want to do the addition of the acid by mass, place the vial onto the scale and push tare. And then 2 grams of the acid solution can be added. I'm going to pipette in the 2 mils, and it should come very close to 2 grams. Shake the vial a little bit. Next, I'm going to pour the contents of vial A into the 0.0050 molar triiodide solution. There's 10 mils here that have been pre-measured. If we created a test kit for you, you should find vials like this within the test kit. Alternatively, you could pipette 10 mils of the triiodide solution directly into the vial A. Or you could also do it by mass. Shake the vial a little. And again, set a timer for 15 minutes and wait. Alright, so that 15-minute time period is up. Here you'll see that the test solution is a shade of yellow. We're going to assay how much of the iodine is present in the solution by applying 125 microliters of the solution to each of these test squares. If you don't have a pipette, you can instead use a squeezy bulb and count 3 drops into each square, like this. The automatic pipette will give you a more accurate result. You will notice that the test solution flows over the thin lines of each of these squares, but is being contained by the thick outer black square. Each of the subdivisions within each square contains a reagent that is necessary to do the analysis. So you have to go back through and make sure the test solution flows over all of these individual subsets of the squares. Start at the top left and work your way down to the bottom right to minimize the contamination between the separate reaction areas. Now we have to gently shake the test card for 3 minutes. You can just let it lie on the table and move it back and forth about 1 centimeter. This technique takes a little practice to master, because if you do it too vigorously, the test solution will escape the squares, and then you will have to repeat the analysis. When you open up this test solution, you'll notice a smell. This is from the degraded antibiotic, and it's perfectly normal. It kind of smells like sulfur. While we wait for the 3 minutes to be up from the shaking of this test card, if you have remaining test cards that we sent you, you can store them in a Ziploc baggie. Just put them into the baggie, squeeze out the air, and seal it. The test cards should stay good for a few days this way. If you leave the test cards in the vacuum sealed package that we sent you, they should be stable for 3 months at 20 degrees Celsius. Alright, the 3 minutes is up. At this point in time, if you have a cell phone camera available, you'll want to take a picture of the test card to track the result in time. Then, you can compare how the test card looks to a set of standard images, shown here. Here, you pick the one that looks the most similar. It's easiest to start by counting the number of blue circles that have developed. In this test card that I've run, you can see that all 12 circles have turned dark blue. So I'm going to look at at all of the standard images where all 12 circles have also tripped. So we have 2 choices here, the less than 0.85 or the 0.90. You can see in the bottom row that in this image the circles are dark blue, but in this image the circles are a lighter blue. In this case, the test card that we just ran best matches the less than or equal to 0.85 milligrams per mil. Since we originally started the analysis by creating a nominal 1 mg per mil solution, this means that the antibiotic must contain less than or equal to 85% of the labeled amount of the antibiotic.